In Decimals 1, we visited Port Talbot and saw Pamela Morgan as she revised the first decimal place and taught hundredths and thousandths. She had some expert observers for her group work, so what did they and the pupils take from the lesson?
Hello and welcome back to Wales, where I'm joined by Pamela Morgan, class teacher, Richard Dunn, maths consultant. And I'd like to thank you, Pamela, for an excellent lesson where the children really impressed me with their hard work and their effort.
Thank you.
Let's look back at the start of the lesson and see how that went.
Can you tell me about these tenths here? 1/10, 1/10. Kerry?
Same value, different appearance.
Diane? Is there anything here? Sam?
No.
Is there anything here? Rachel?
No.
But I was interested in the way that you used 0.1 as opposed to 0.1. Any particular reason for that?
It focuses on the fact that it's 1/10, right, and then you add the zeros later. So I understand that is there anything here? No. Is there anything after the 1? There's not. So it doesn't hide the fact. If the more numbers you put on to introduce it, the children can get confused.
The other fact I noticed was the way you used the term same value, different appearance, where you had the tenths, the word 1/10 written down. Do you find that a powerful tool in helping the children understand?
Well, to understand, yes, and to recognise there are different ways of writing it down, because they will come across it and they recognise then that if they see that it always means the same thing. How much is there here, David?
45 thousandths.
Diane. How much is there here, David?
34 hundredths.
Caius. How much is there here?
23 tenths.
Diane. I'm not going to say the number. I want you all to write it down accurately. And with your partner, please ask, how much is here? How much is here? Remember, what are we looking for?
How much is here? 31 tenths. How much is here? 3,135 thousandths.
The reason I work in pairs like that is that they're constantly then hearing the language, they're hearing the words pronounced correctly, and they sort of check each other. And then they actually begin to ask the questions themselves. So it's not just answering, they are asking the questions. So if they're asking the questions, they must be in control of information, they must be in control of knowledge.
I like the use of the whiteboards. They seem very confident in the way they were using those and working together. But there does seem to be a little bit of a problem at this point here.
If you write it down on your whiteboards with your partner. Right, some of you have got this, and some of you have got that. How much is here, Richard?
12 hundredths.
12 hundredths. And how much is here, Richard?
12 tenths.
Right, can you have a look at your answer and have a think about it? What have you got written down, Richard?
12 hundredths.
And what are we looking for? 12
tenths.
That problem then gave us an opportunity to clarify issues. If you always give things that they're safe with, then these issues never come up. It's only when issues like this come up and a little bit of confusion, can you clarify and discuss it and then move on? So I think that provided a really good opportunity to analyse the answers.
So the whiteboard gives you that instant feedback?
Absolutely, yes. And because they're working as a group, they're not threatened by giving an answer. If they were all individual whiteboards, then they have responsibility for their answer, and it's more threatening. But as a group, after discussing it, they sort of take collective responsibility, so they don't feel so threatened with it.
The opportunity you had here of asking the child how much is there here, how much is there here, and seeing this is actually 12 hundredths, meant that that problem was resolved with the use of the language, which has been set up as part of the learning system.
Yeah, and I didn't correct him. I said, right, go back and look at your whiteboards and read it yourselves, and then come back with the answers. So you have a consensus of opinion then.
Given the autonomy of Welsh schools, we travelled just a couple of miles to see the same curriculum material being taught quite differently.
Traditionally, I've used my counting stick
or my magic stick I tend to call it, for a long time for all sorts of different types of things. But if I'm teaching decimals, I would automatically say that this is 0, this end, and that would be 1, that end. So it's split up into divisions of 10, so automatically we could just say 0.1, 0.2, 0.3, etc., etc. I would then go on to use a blank number line, where I would draw it on the board, but then they could actually see when they divided into quarters, then the half, then the 3/4, and they should be able to see then that it's between 0.2 and 0.3, so they would be able to do it as 0.25.
I would show the children a blank 100 square or 100 grid. We would then talk about how many rows there are, how many columns, and then we'd establish that there are 100 small squares in the larger square. I would then ask the children if 1 square is worth 1 penny, how much the whole square would be. And then again, hopefully the children would arrive at either £1 or 100 pennies. I'd further develop that. To write it in pennies, we'd write it as 1 pence here. Although they may look different, they actually got the same value. So then what would be the value of 2 squares? And again, depending on the ability of the children, we would then move on quickly then with 2 pence. And again, if we wanted to write it in pounds, it would be 0.02.
I mean, that was very good. I mean, people here using a number of well-established methods which appear in texts, but we meet 16-year-old school leavers who are quite capable of doing that and getting the right answer, and yet asked immediately afterwards to deal with that in metres, and that in metres claim not to be able to do that, when in fact they've just done that. Because where we teach with money, the students locate the idea of decimals far too closely with money.
So I just said this morning my children would do a measure, and they independently made the link between the decimal and a millimetre being 1,000th of a metre, and also then a millimetre being 1/10 of a centimetre. So they wouldn't have done that if I had taught decimal through money, because that's where their knowledge would have been located. But by doing it this way, they have the knowledge and then they have the confidence. And by thinking and being so confident with the decimal, they made the link themselves with a completely different lesson.
Relating decimals to knowledge Year 4-5 children will have already from fractions is another useful experiential link, one they've exploited in the next suburb.
Having had the problem of decimals relating a half and a quarter and an eighth back into decimals, we've got over the problem by using an on-screen calculator. If a quarter is 1 shared by 4 equal parts, what is an eighth? And hopefully they'd be able to tell us that it's 1 shared by 8 equal parts. The answer then is 0.125. And we could also introduce inverse operations there as well. If we times it back by the 8 equal parts, what should the answer come back to 1 whole at that point?
I think what my concern is that at this early stage, I'll be reluctant to worry about things like this. Because what we need is real familiarity with this as a kind of literal translation of the vulgar fraction equivalent. And then do this, as Craig did so well, to do this rather later, when our familiarity with that and the fact that we're always getting this sort of thing then turns into making the familiar unfamiliar, which is a kind of cognitive surprise. And then when we begin, and exactly like this, to use the calculator to look at this, we're then so familiar with this that when we see something like that, we can actually see what each of these mean and what they mean in combination.
Well, thank you for that, Richard. Now we can have a look at some group work. And I thank you, Pamela, for making us work just as hard as the children in this one.
6 tenths and 3 tenths and 1 tenth equals 10 tenths. So we have to put the 6 and 5 and the 1 equals
12. I think the rigour of it, John, is when they say 100th add 900th is 10 hundredths, rather than put down a naught and do something else with the 1, to actually write 10 in the manner in which you'd normally write 10.
Yeah.
With the proviso that it's like that, but it's still 10 hundredths.
They were quite competent in the way that they actually read out the final computation. So they did say 12 point, no tenths, no hundredths, 8,000s. So they really did grasp that element of it, which was pleasing to see.
Yeah, I think what you brought up there is an issue of the way they were working in groups. Because if that had been in a book and the answer would have been correct, you'd have just given it a tick. You'd have assumed that they had an understanding, or really understood the fact that they had then become 1/10. So by working as a group and hearing them discussing it, you're more aware of their level of understanding and where to take them, where the issues are, and where to take them on the next step.
Yes,
yeah. And your mentors were extraordinary in the vision they required.
Yes, absolutely. And as the other children become more confident, the roles will change in the groups.
It's not 5,000s, take away 2,000s. 2,000s, take away 5,000s. We've done it before. With whole numbers. Can you remember what to do?
Yeah, it's funny counting, isn't it? Yeah. It's called funny counting.
2 thousandths take away 5 thousandths. Oh, you can't do that. And then there's a little pause, and then somebody said, funny counting. And they then were able to go like that. Say 12 thousandths take away 5 thousandths is 7 thousandths. 5 hundredths take away 2 hundredths is 3 hundredths. 3 tenths take away 1 tenth is 2 tenths. And with one little sort of prompt from the mentor, there was a spark of realisation that you could employ the same methodology, and therefore they'll eventually be being able to deal with things like this in a very rigorous way, knowing exactly what they're doing at every stage.
It's giving them real understanding so that they can use the knowledge.
So it's not about, often as the case may be, it's been where children may have been told in the past, ignore the decimal point, and then you apply it afterwards. So you work that out as a normal whole number digits.
You empower them and you give them the knowledge and the understanding, and then they can use that and apply it. And they learn so much from each other. When they're discussing, they're constantly listening, they're constantly hearing, they're constantly asking questions of others, which you don't often have. And that gives them the confidence then and reinforces their own understanding.
Yes.
Right, well, thank you, Pamela, for inviting us into your lesson today. And thank you, Richard, for your advice and your support. We hope you enjoyed the lesson. Goodbye.